Hey everyone, welcome to the channel Vidyut Yog. In this video, we'll describe how to calculate ABCD parameters of transmission line. In this video, we'll discuss how to make the connections for calculating ABCD parameters and how to do the calculations by the observation. In short, we'll discuss how to calculate ABCD parameters practically by using the experimental setup. So before starting the video, those who are new to this channel, please subscribe the channel. We know that the transmission lines are classified into different type, like short transmission line, which is having the distance up to the 80 kilometer and voltage is below the 20 kV. Then medium transmission lines, those are having length of 80 to 240 kilometer and operating voltage of 25 kV to 110 kV, and long transmission line, which is having the distance greater than 240 kilometer and having the high voltage. So resistance and inductance, these are the uh, parameters of the transmission line, as well as capacitance is also one parameter of the transmission line. Resistance and inductance make the series impedance, and capacitance and conductance make the shunt admittance of the transmission line. Shunt conductance usually neglected in power transmission line according to the length when calculating the voltage and current. So in this video, the title of the experiment is ABCD constant of the long transmission line. Aim of the experiment is to find the ABCD parameters for given equivalent pi model of long transmission line. So before starting the practical discussion, quickly we'll go through the theory. The ABCD parameters of transmission line are usually used to represent the sending end parameters like sending end voltage and sending end current in terms of the receiving end parameters like receiving end voltage and receiving end current. So Vs is equal to AVR plus VIR, Rs is equal to CVR plus DIR, where ABCD are called as the transmission line constant, and their value depend on the magnitude of circuit parameters. So if the circuit is symmetrical, then we can observe that A and D, those two parameters, those two constants are having equal value. That means if A is equal to D, the transmission line is having symmetrical characteristic. And if the transmission line circuit is reciprocating, then we will observe AD minus BC is equal to 1. So these two properties will be helpful to determine the characteristic of the transmission line. Now, other apparatus in this experiment, first of all, there is a need of static pi model of transmission line, then AC voltmeter of 0 to 300 volt, AC ammeter of 0 to 2 ampere, then dimmer stat or auto transformer, which is having the range of 0 to 270 volt and 10 ampere, and wattmeter, which is having the range of 250 volt 2 ampere. So this is the static model of the transmission line. In this, the parameters are shown like resistance, inductance. Then, since this is the pi model of transmission line, capacitance are also in parallel. This white color indicate that this this is the continuous line that is internally connected, and if the white line is absent, that means it is internally open and we need to connect through the external wire. So why such type of the arrangement is made in the circuit? Because we can here, with the help of this, we can select either up to this portion of the transmission line, or we can extend up to this by connecting this to wire, these two terminals. For by connecting these two terminals and these two terminals, we can extend the length of the transmission line. So we can make the short transmission line model, medium transmission line model, or long transmission line model by using the same experimental kit. So right now I am using the portion up to this. That's why I have connected this open portion with the help of the wire. Okay, so we'll use this in this experiment. We'll discuss it later. Now, what is the another apparatus, or what are the apparatus which we have discussed? That is, this is the dimmer or auto transformer having the 0 to 270 voltage. Then AC ammeter. Then of course AC ammeter should be connected in series. Then AC wattmeter. Wattmeter is having the four terminals: M for main, L for load, C for common, and V for voltage. So regarding the wattmeter connection and details regarding the multiplying factor, I have already uploaded one video on this channel. You can go through that video. Then there is need of one AC voltmeter. So AC voltmeter should be connected in parallel. Now regarding the connection diagram. So for calculation of the ABCD parameter, this is the connection diagram. So whatever the pi model of transmission line which we have discussed, this is the pi model of transmission line. That is, it shows the admittance, half admittance y dash by 2, half admittance y dash by 2, and it represents the impedance of the transmission line. So this is the lumped form, but for our experiment, we'll use the entire experimental setup. Now, how the connections will be made? We'll provide the single phase supply, like between R phase and neutral. We'll provide the single phase 230 volt 50 Hz AC supply to the dimmer or auto transformer. So this is the symbol of dimmer or auto transformer. Of course, it is protected with the help of the fuse, or mostly practically we use the MCB. Then to measure the sending end voltage of the transmission line, we have connected the one AC voltmeter here. Then to measure the sending end current of the transmission line, we have connected one AC ammeter. Then to measure the power of sending end parameter, we have connected the wattmeter, which is having the four terminal: M for main, L for line or load, C for common, and V for voltage. It is having the 250 volt 2 ampere capacity for range. Then this is the entire transmission line, and at the receiving end of the transmission line, to measure the receiving end voltage, we have connected one AC voltmeter in parallel, and to measure the short circuited current, we have connected the AC ammeter at the receiving end of the transmission line. So what we'll do in this experiment, while calculation of the ABCD parameter, we need to measure the sending end parameter as well as receiving end parameter, that is sending end voltage, sending end current, and receiving end voltage and receiving end current. But for calculation of the ABCD parameters of the transmission line, we need to connect this transmission line under no load as well as under short circuit condition. This what we'll do, first of all, we'll provide this 230 volt AC supply to the sending end of the transmission line, and at that time, in one case, receiving end will be open, will measure the sending and receiving end parameter, and in second case, receiving end will be short circuited and will measure the sending end and receiving end parameters. So right now there might be the confusion in your mind, but whenever we'll discuss the observation table, you will get the clear idea, as well as we'll go through the video. So I repeat, in first case, we'll provide the supply to the sending end parameter, and we'll take the reading for two cases: one receiving end open and receiving end short circuited. In second case, what we'll do, we'll provide the same supply to the receiving end, and there will be two cases whenever we'll provide the supply to the receiving end. First case, sending end will be open circuited, and second case, sending end will be short circuited. And in both cases, again we'll measure the sending and receiving end parameters. That is sending end voltage, sending end current, receiving end voltage and receiving end current. And those parameters will be used for calculation of ABCD parameter. So that we'll discuss in detail. Here, this is the connection diagram. So what we'll do, first of all, we'll provide the single phase 238 supply through this dimmer or auto transformer. Then this is the sending end parameters. These are the receiving end parameters. So I have used the model from this to this length. So I will provide the sending end voltage through this auto transformer. Then for measurement of sending end current, this AC ammeter is connected in series. For measurement of sending end voltage, this voltmeter is connected in parallel with the auto transformer or parallel with the sending end of the transmission line. Then regarding the wattmeter connection, main terminal is given from this auto transformer or dimmer. Then L terminal is connected, that is line or load terminal is connected to the positive terminal of this transmission line. Then M and C are internally shorted and V terminal is connected to the negative of this auto transformer. Okay. Then this transmission line model is present. So this is the connection for providing the supply to the sending end of transmission line. Here we'll observe the reading for two cases. In first case, we'll open circuit this receiving end, and hence only voltmeter will be connected in parallel to measure the open circuit voltage. And in second case, whenever the supply is at sending end, we'll short circuit the receiving end with the help of the AC ammeter. And while providing the supply, what we'll do, in case of the open circuited receiving end, we can provide the supply up to the full extent, like up to the 230 volt, because receiving end parameter is open. But whenever receiving end is shorted, at that time we need to provide the voltage in such way that receiving end current or short circuited current will go up to the 1 ampere only. So of course at that time sending end voltage will be less. It is nearly equal to the 40 or 43 volt, and we'll take the reading. In the second case, what we'll do, we'll provide the same supply to the receiving end. We'll make the arrangement for measuring the sending end current, sending end voltage, their sending end power with the help of the wattmeter. But again here there will be two cases. First, receiving end will be open and receiving end voltage will be measured with the help of the AC voltmeter. And receiving end, second case, receiving end will be shorted with the help of the AC ammeter. Again in shorted condition, will provide the less voltage like up to the 40 or 43 volt, such that the receiving end current will be the maximum up to the 1 ampere, and will take the reading of sending end and receiving end parameter. So to get the clear idea, I will go through the one video for which I have made the for connection. These are the dimmer or auto transformer connection. Then AC ammeter is connected in series with the to the dimmer. Wattmeter is having the M, L, C and V connections terminals. Then these are the sending end parameters. These are the receiving end parameter. I have made this connection for receiving end shorted. So I'm receiving end is shorted through the AC ammeter. Okay, wattmeter will measure the sending end power. Okay, so I have connected the 0 to 1 ampere range because we'll provide the voltage up to the 1 ampere current, and this is the voltmeter for measurement of the AC voltage. So I think now from this video you might get the idea about the connection. Now we'll go through the observation table. So in observation table, as we have discussed, there are two cases. In one case, we'll provide the voltage to the sending end of transmission line, and in second case, we'll provide the voltage to the receiving end of transmission line. So whenever the voltage is applied to the sending end, that is for which case we have already go through the video regarding the connection. There are two cases: receiving end open. At that time, sending end voltage is 230 volt. Since receiving end open, we have provided the more voltage. At that time, it is observed that sending end current is 0.05 ampere. Wattmeter is current is 0 and voltage is nearly 40. So wattmeter reading is almost 0. I'm not going to consider this power or watt readings because those are not useful, not required in the calculation of ABCD parameter. Then how will calculate the impedance? So ZRO is nothing but impedance with the receiving end open, which is calculated with the help of the sending end voltage divided by sending end current. So 230 divided by 0.05, that is 4600 ohm. And at that time, receiving end voltage is observed to the 247 volt. The voltage is increased maybe because of the Faraday effect. Then second case, receiving end short circuited. At that time, sending end voltage is 430 volt. We have applied the less voltage because the receiving end is shorted, and that at that time current will be more. So we have provided the voltage such that shorted current or current flowing through the shorted path of the ammeter will be reach up to the 1 ampere. Then at that time, ZRS, that is impedance with receiving end shorted, is given by Vs upon Is, that is 43 upon 1, that is 43 ohm. Second case, voltage is applied to the receiving end, exactly opposite to whatever the connection we did. We have to provide the voltage to the receiving end and we have to measure the parameters at sending end. Again, there are two cases: sending end open circuited. At that time, receiving end voltage is 230 volt. Since sending end open circuit, we can provide the 230 volt. Then current is less 0.05 ampere. At that time, say, impedance ZSO, that is sending end open, impedance with sending end open is VR upon IR, that is 230 upon 0.05 ampere, that is 4600 ohm. And sending end short circuit, at that time, of course, will provide the less voltage to the receiving end. VR is equal to 43 volt, IR is equal to 1 ampere, and impedance ZSC, that is impedance with sending end short circuited, is given by the formula VR upon IR, that is 43 upon 1, that is 43 ohm. So this is the observation table. Now from this reading of uh, impedances, we can calculate the ABCD parameter. So what is the how to calculate the A parameter? A parameter is calculated by the formula under root of ZSO upon ZRO minus ZRS. So ZSO is 4600, ZRO 4600, and ZRS 43. So we'll get the parameter A is 1.0047. B parameter, that is ZRS, is equal to under root of ZSO upon ZRO minus ZRS. Here ZRS is 43 under root of 4600 upon 4600 minus 43, that is 43.20. So we have calculated A and B parameter. For calculation of C parameter, formula is 1 upon under root of ZSO in bracket ZRO minus ZRS is equal to 1 upon under root of 4600 in bracket 4600 minus 43, that is 2.184 into 10 raised to minus 4. D parameter is calculated as ZRO upon under root of ZSO in bracket ZRO minus ZRS, that is equal to 4600 upon under root of 4600 in bracket 4600 minus 43, which is equal to 1.0047. Now from values of ABCD parameter observation, it is clear that A is equal to D is equal to 1.0047. So from which we can conclude that this transmission line is having the symmetrical characteristic. Now regarding the AD minus BC is equal to 1, you can put these values of A, B, C, D and you can calculate. You can observe that AD minus BC is equal to 1 for these readings, and that's why transmission line is having reciprocating characteristic. Thus, we have discussed how to calculate the ABCD parameter by conducting no load test and short circuit test on the transmission line, and how to conclude regarding the characteristic of the transmission line, that is whether it is symmetrical or reciprocating or both symmetrical and reciprocating. Now conclusion, ABCD parameters of the transmission line are calculating using no load test and short circuit test on transmission line, and this transmission line is having the symmetrical and reciprocating characteristic. I hope this video is useful for you. Those who are having the doubt regarding the uh, how to connect the wattmeter or how to calculate the multiplying factor of the wattmeter, I have already uploaded the video regarding that topic. You can go through that. I hope this video is helpful. Again, I request those who are new to this channel, please subscribe the channel. Thank you. Thank you very much.